Today's presentation is about one of the pioneers of science, Alexander von Humboldt. And he did part of the journey that we did, and he went to visit Tenerife. And the centerpiece of my presentation today is about Humboldt's visit to Tenerife. But I'm going to give you a little bit of an introduction to his life and his early years, and also the rest of his great journey through to the Americas and his contributions to science. So there's two more people coming, so let's give them a chance. And the second part, or the last part of the presentation, would be about Darwin, but the other conversationalist, Peter Damisch, he was talking about Darwin, so I think I'll skip that because this is just the add-on to see how Humboldt influenced Darwin. But let's focus on Humboldt today. Hello, good to see you. So, Humboldt's visit to Tenerife, and let's start here. Tenerife, where we've been, was long known by sailors as a landmark. It was very important because it sticks out above the clouds. It's 3,700 meters tall, and this is something sailors could see from a vast distance. And there's this old drawing, a Dutch drawing, where it says Pic de Tenerife, and it actually shows this rather well. It shows a bunch of ships in the ocean in front of Tenerife, and it shows this, well, exaggerated large tower of a mountain, and this shows the peak being above the clouds. And on the right hand side you see Teide above the clouds, and this sea of clouds actually was one of Humboldt's descriptions. He noted that this is a weather phenomenon that's actually quite important, and it has severe effects also on the botany of the island of Tenerife, and he was the first to describe this in scientific terms. So, in fact, the peak of Tenerife was actually long considered to be the highest point on Earth. And legend said that if you go up there, you would be so close to the sun that you would burn. And Humboldt, being Humboldt, he didn't quite take that story so true. And he set out to challenge this. And, well, the exact height was also not known, and this added to the mystery of Tenerife and Teide. And this led to a whole bunch of people trying to go there and establish the height of the volcano. So this was a scientific fashion back there in the late 1700s, and I'll talk a little more about this. In addition, Humboldt was in its heart, I think, a volcanologist, because whenever there is an eruption, he was drawn to it. And there was the eruption of 1798. There was earlier ones, recorded ones in 1704 on Tenerife, 1705 and 1706, but when he prepared his big journey, there was the 1798 eruption, and he couldn't get there quick enough. He only arrived there in 1799. He came a year late, but given the traffic means at the time, it was reasonably speedy, I would say. So he missed the actual eruption, but the rocks were still warm when he arrived. So, he was of lesser nobility in Prussia, in northern Germany, and he was keen to explore all these things for himself, the volcanoes and things, and he enjoyed puzzles. And he was keen to establish the height of Teide. This was one of the great challenges he set himself out to conquer. And the question of how basaltic rocks form was also a big scientific debate at the time. We now know that lava comes from volcanoes, and if the silica content of the lava is low, it makes basaltic lava rock. But at the time, there was another school of thought, and that believed that basaltic rock would form from precipitation from ocean water. And this was the school of the Neptunists versus the Plutonists. The Plutonists believing that molten rock would come from depth, and the Neptunists believe it's all down to ocean water precipitation. And Humboldt would make a contribution to that as well. So, and in addition, he had a great interest, a vast interest in plant life and the interaction with human beings. So, his early years, well, he was born September 1769 in Berlin, and the Duke of Brunswick was actually his godfather, Back at the time, the Hanoverians were in charge of Hanover as well as the British Empire. And so the Duke of Brunswick was very closely linked there, and he was in fact his godfather. So, and this opened a lot of doors for him later on with his journeys and also with his scientific endeavors. His family estate is in Tegel, which is at the outskirts of Berlin, and actually there was an airport there, but I think it's closed down now, so maybe one of you has actually set foot on Tegel Airport at some point in your travels. His father was Alexander Georg von Humboldt. He was an officer in the Prussian army. His mother was of French descent, Cologne, and he got his education from a private tutor who was very famous at the time, and his name was Kund, but I haven't followed up very much on him. So in 1779, the father dies, and he enrolls at the University of Frankfurt Oder, and together with his brother Wilhelm, and Wilhelm later became a politician in Prussian service, and the younger brother Alexander became the scientist. He begins his studies as a civil servant, but he doesn't enjoy it. So it's not the thing he wants to do. He learns very quickly. In 1779, the father dies, enrollment at the university, I said this, he begins his study, but with moderate success, and here's an image in the lower right together with his mother. And he then later enrolls at the University of Göttingen, where he stays for a year, and then he starts traveling, and this is something that gives him great joy. He does a Rhine trip with Georg Forster, who was actually sailing with James Cook before, so he had somebody to speak about great adventures and travels. He then does a year at the Trade Academy in Hamburg, and then he travels to the Netherlands, to France and England. So he starts to travel a little bit further each time. And in London, he is introduced to the president of the Royal Society, Joseph Banks, and he's shown the South Sea specimen collection, and that really sparks his imagination. So he then starts to work in a professional capacity. He starts to be in the Prussian mining service in 1791, and he starts to train further at the Mining Academy in Freiberg, Saxony, where he graduated in 1792. He was greatly influenced by one of his professors, Abraham Werner, and he was the archetype of the Neptunist. He was the person who pushed the concept of lava forming from ocean precipitation. So when Humboldt left university education, he was very much convinced that lava rock forms from ocean precipitation rather than from actual volcanic activity, as we know today. So he then works as a mining inspector in several places, and he's very successful in that. Some of the mines he is overseeing suddenly start to have an increase in production, and one of them is said to have increased production by factor 8, so he's very good at that. And he starts to publish mineralogical observations from his various trips, and he then continues his travel. And he goes to Austria, Switzerland, he looks at the mountains, the landscapes, and he also gets fascinated by cave botany, and he actually writes an early account on cave botany, which is actually reasonably acclaimed at the time. This gets him to be invited to various discussion circles, and he's invited to the Weimar Classic Circle, where he interacts with Goethe and Schiller, some of the great German poets at the time. And he has a second trip to Switzerland in 1797. But then something severe happens, and that is his mother dies in November 1796. It's a bit unclear, but the way I read it is that his relationship with his mother was a little complicated. As soon as the mother dies, everything changes. And I think she must have had a great constraint on him somehow, because as soon as she is gone, he stops all his jobs, he inherits the family wealth together with his brother, and he starts immediately to prepare for his great journey. So everything all of a sudden changes in his life. He throws off all the shackles and takes the money he inherits and gets ready for his great adventure. So the idea is that he gets a passport from the Queen of Spain, and he's allowed to travel, and he goes from Spain all the way to the Canary Islands, where he spends this 1 week on Tenerife, but then he also goes on to South America, where he travels in northern South America. He travels through several countries that are today Venezuela, Ecuador, etc., Mexico, and he visits the US as well before he comes back, and the trip takes him several years. So let's talk a little bit about his visit to Tenerife. He was only there for 1 week, believe it or not, but he filled his week with a lot of excitement. And he arrives there June 19th, and he leaves June 25th of 1799. He visits Teide volcano. He goes all the way up to Teide. He visits La Laguna and the Anaga Peninsula, and he stays in the fertile Orotava Valley, where a lot of the nobility of the time was living, and where there was a lot of agriculture. And he does a lot of research along the way, and I'll give you a few highlights of that. And he was, of course, enjoying the volcanic experience because he started to question the belief that volcanic or basaltic rocks would actually form from ocean precipitation. Initially, the belief coming from his university education was thrown all overboard when he saw the volcanic landscapes of Tenerife. So he also had a very busy social calendar. It's said that he had a bit of a flirt with one of the daughters of the local nobility, and it didn't come to anything, but there's a note in his diary saying that he liked this person very much, and he was thinking about coming back after his travels, which he never did. But anyway, there was a bit of a romantic fling there, as far as I can tell. And he also had a plan to go to San Juan de las Ramblas in northwestern Tenerife, but he had to cancel that in the end because the ship was sailing. So he couldn't quite do all the things he wanted to do. The big scientific issue at the time was the height of Teide volcano, as I said. So he sets out to estimate the height by triangulation. And he concluded after his initial calculations that he will not be burned by climbing the volcano. So this was a big achievement, concluding this, because that means he could set out to actually go up the volcano. And there was an estimate from a few years before from a French team led by Charles Bourdin, and Charles Bourdin had an estimate of 3,700 something meters, and Humboldt's estimate wasn't far off. So here is a table with all the various estimates, and they come in all different units, and this led to a lot of confusion. But if you look down, you see Alexander von Humboldt, 1799. He concludes it's 3,736 meters. Bourdin comes with 3,713 meters. All the other estimates beforehand are completely off and non-systematic. And Humboldt is the first that is actually close to a previous estimate, to Bourdin's estimate, and that really gives him a lot of support from the scientific community, and later estimates are pretty close. So he was a little off. The real value is 3,718 as we measure it today, but he was reasonably close given the methods of the time. The intriguing thing here is that he realizes very well that it wasn't his main achievement. He notes that Bourdin was the person who actually really got it right. And in fact, Bourdin was actually closer than Humboldt's estimate in the absolute terms. So he coins this phrase that I list here at the base. There's 3 stages of scientific discovery. And I still believe it's very true. He says, first, people deny it's true. Then they deny it's important. And finally, they credit the wrong person. So, but he got the fame, and he was probably quite happy to accept it, but he was aware that the achievement was actually on the shoulders of someone else's work. So, here again, different images, including one of the early photographs of Teide volcano, and in the top right, there is the eruption of 1798, drawn by another Frenchman who was there at the time, the eruption that Humboldt did not actually get to see live, but he saw the rocks. And to my understanding, according to his diary, the rocks were still warm when he arrived a year after the eruption. So this is how Teide looks today. This is a postcard in the top left, and when you have an opportunity to go up to Teide and you look down, you see these lava rocks, the rough landscape of the lava rocks, and there's the Las Cañadas caldera, the big depression in which Teide volcano sits, and it's all very barren up there. There's very little vegetation because it's very high altitude. It's the level where altitude sickness really kicks in, and this is what Humboldt experienced. He did not have a cable car at the time, but he had mules, I understand, and he had porters. The relationship with his porters was a bit complicated, at least when you read the diaries. He considered the porters as a little bit on the lazy side, and he was giving out about them. He said they had too many breaks and were not enthusiastic enough about the exercise going up the volcano. So he then went to the peak, and there at the peak we see, of course, sulfurous activity, but the air is also very thin, so it's hard to breathe up there, so I don't blame the porters. And Humboldt, however, he was so enthusiastic that he wanted to see it all and he wanted to experience everything. Then there was another incident up there with the porters because of this place here, the ice cave. The ice cave is a little tube, a lava tube up there close to the peak, and during the nights when there's precipitation, there's water coming in, and because very often it goes below zero, there's ice in there. And back in those days, ice was not a very common commodity, so the porters were keen to bring ice down to the city of Orotava to make sorbets, for example. So they would sell the ice to make ice creams of some sort. So, and the porters, of course, being up there, they stole away from the actual activity, and they were, well, chipping away on the ice in the ice cave. And Humboldt was not impressed with that. He thought this was a low activity, but he couldn't stop them. So they actually brought ice back at the same time from Humboldt's expedition. So Humboldt's, he is also struck with the landscape. It's a very barren landscape. Many people still today call it a Martian type landscape. And he notes that at above 2,000 meters above sea level, the vegetation is almost non-existent. This is a very important observation because he realizes that vegetation links with altitude. And he then notes that below about 2,000 meters, there's the ring of forest, the Corona Forestal, and I'm showing it here in that image. You see it's almost a sharp line where the pine trees stop and where the vegetation dies out. And in this Google image there in the lower left, you see a green kind of band going along the hillside. That's the Corona Forestal between about 1,000 and 2,000 meters of altitude. It's only at that level, and it actually feeds from the clouds. There's very little rainfall, but there's a lot of cloud activity. And Humboldt notes this, so he understands that the sea of clouds is a major contribution to this, and this determines the vegetation at this altitude level. So, and here's his description. He shows this sea of clouds here in this sketch, and he starts to note the changes in vegetation with altitude here on the right-hand side, and he notes the different plant types and the different features in this sketch here. So, well, this is from 1799, and actually many of my students can't do sketches that well, so I'm really impressed with some of his work. And importantly, he notes that very low down at low altitude near the coast, you have beautiful conditions for agriculture, and the higher you go, the more forest-type vegetation you get, and above 2,000 meters, about 2,000, 2,200 meters, vegetation dies out almost completely. So this is where he starts off in the Orotava Valley, very fertile, close to the coast, and this is still a big hub for banana growth today, so a lot of banana plantations in the Orotava Valley. It's the other side of Tenerife, not the one where our ship has been spending time, so if you have a chance to go to the other side, you see that's the weather side. There's more rainfall on the northern side, and therefore you have more agriculture. So he comes up with this summary sketch, and he recognizes that changes in altitude are similar to changes in latitude. And this was also a very important conclusion. Basically, if you go north on the globe towards the Arctic regions, vegetations also become sparse and eventually die out. So this is something that he worked out from his visit to Tenerife, in fact, and his knowledge about the globe. He concludes that the height of Teide is about 3,700 something meters, as we know today, 3,718, and he reports these vegetation changes, and the sketch there to the left shows his observations with palm trees and banana plantations in the lower part, agriculture leading up to shrubs and eventually pine forest, and finally to the Pico de Teide, the volcano that's sparsely vegetated at all. In addition, he makes observations about lava rocks, and he struggles a little with this because he comes from this school that made him believe that lava rock actually forms from precipitation of ocean water. But looking at these features, the lavas negras, the last eruption of Teide volcano, he concludes that something else is going on. This doesn't look like systematic ocean precipitation that would happen over large areas. This really looks like it's originating on top of the volcano, it's flowing down the volcano, and then it stops. And if we look at the lavas negras, you still see the channels and the channelized flow there with the levees at the side and the more hollow parts in the middle, and he works out rather swiftly. This concept he was taught at university probably doesn't hold. Later on, he actually witnesses real volcano eruptions in the Andes, which seal the fate of the hypotheses, and he writes very clearly that volcanic or basaltic rocks, they form from volcanic eruptions, there's no doubt. And when you look at some of the rocks, for example, here in the top right, you see some flow textures, and he observes them as well. This is a microtexture within the rock, but you see the swirls, and this is almost inconceivable to produce at the ocean floor in a calm environment where you precipitate particles. So this has to do with flow of a magma. And this is the map today. When we look at the lavas negras, they clearly originate at one point and they flow out from a central high altitude point, which is the volcano, and they never reach the sea. So the concept of ocean precipitation starts to crumble in his mind at that point. Another important aspect is when he stays in the Orotava Valley, and here's an image of the Orotava Valley from an old postcard and a more modern picture on the right-hand side. He sees several volcanic cones in the Orotava Valley, and he starts to talk to people. And some of the people say, oh, these cones are very recent eruptions. And some of the Aboriginal legends report that they are very, very young eruptions. And he notes it down as having only erupted a few decades before the Spanish conquest. And this was actually a belief held for many, many centuries. Only very recently have we worked out that this is not entirely true. Radiometric dating reveals that these cones are actually 20,000 years old. So there was maybe a little bit of misinformation there, but his word had a lot of gravity, and for a long time, until only about 10 years ago, many people considered these cones as very young volcanic eruptions. This is, of course, important when we think about hazard assessment in the area. But good news, they're not very young. So the other thing he notes is that this is a beautiful landscape, and he notes 3 of those cones. But today, if you go there, there's only 1.5 of them left. The other one has been quarried away, and one of them is only half present. And you just about see that here. Let me see if I get this. So here you see one of the cones, and there's a tiny little white dot on top. This is a church tower. And this is the other cone. There's a hotel on top, and you see the quarried side here, the rock face, the reddish rock face, where people have been quarrying it away. And the third one was in between them, but it's gone entirely by now. People have quarried it away and used it for agriculture and as a supplement for building. So there is the Humboldt Mirador, the viewpoint of Humboldt, with a monument to Humboldt. There is a bronze monument where he sits, and there he got a bit melancholic the day before his departure, and he said, I'm leaving almost with tears in my eyes. I would like to settle here. And I think the little flirt he had with a local lady may have added to this sentiment at the time. But he loved the place, and he was obviously very impressed, and he notes at this point already that this is a very good soil for agriculture, and we talked about it in other presentations. This is something that is widely used today all over the Canary Islands. And it led even to the wines from the Canary Islands to be drunk at the Vienna Congress in 1816, and this is a concept of supplementing the soil that is increasingly widely used. And if you have some of these little pebbles at home in your flower pot, this is actually an artificial reconstruction of the concept of these little lapilli. And they store the water better, and they allow for micro life to flourish, and this is good for your plants. So after the time on Tenerife, Humboldt leaves for the Americas, and he arrives in Caracas in November, and then he stays there in Caracas and surroundings. Then he goes to Venezuela, he explores the Orinoco, he goes to Cuba, he goes to Colombia, Ecuador, and Peru, and he has this rather amazing experience at Chimborazo volcano. And I'll talk a little bit about this, although I don't want to go into too much detail about his American journey, because we've obviously been traveling to the Canaries, so I'd like to focus a little on this. But here we see his travel journey from the Canaries all the way to Venezuela, to Caracas, and then he travels down the Orinoco, he goes up to Cuba, and then he goes back down, and then he explores Chimborazo here, and then he goes back upwards again to Mexico, and then he goes to the US, and then he spends a little bit of time in the US, and then he travels back to Europe. In the US, he actually meets the president, Thomas Jefferson. He's invited to the White House, so he had a dinner there, I understand, and so a lot of doors were opened for him. Chimborazo is one of his main study sites, and he was really impressed with Chimborazo because he sees the changes in vegetation with altitude again. He recognizes the patterns from his observations on Tenerife, only that Chimborazo is a lot taller. It's 6,263 meters tall. And if you have the beginning of altitude sickness at 3,700 meters on Teide, you can imagine how it feels to be at 6,200 meters. This is really serious. So he tries, in his enthusiasm, he tries to climb Chimborazo, but he fails. He makes it up to 5,878 meters, and there he's so unwell that he decides to turn back. My personal record is at 5,335 meters, and all my team was already really unwell, and literally unwell. So, and I was there with this Chilean colleague, and we completely lost our sense of time. It was almost, well, mystical, almost magical. The rest of our team said, "You guys were away for hours," and to us it felt like we've been hiking for half an hour away from, our base camp, and everything changes at this altitude. Your perception of time and distances, everything is not the same. And the notes in Humboldt's diary are very confused at that point. So you could really see that his thinking wasn't all that clear anymore. He was really suffering dreadfully from altitude sickness. And the last 400 meters of the volcano are not managed by him at that time. He is thinking about trying it again, but he never finds the time to do so. Nevertheless, he makes a lot of observations on the way, and the images here show the sonation that he observes at the volcano. And then, of course, he also shows llamas here in his sketches. And he has a whole crew of porters, but he gives up at 5,878 meters. At least that's what we calculate his maximum altitude of the climb to be. And he never quite gets over this, that he didn't make it. But, well, there's a limit to almost everything in life. So he writes down his observations, and he's meticulous about them. And this is his geography of the plants in tropical countries, and this is particularly on the Andes. And you see here in the center of the drawing, he shows an erupting volcano. He has seen eruptions at that point, so his thinking process from his university education to his initial questioning on Tenerife to eventually seeing eruptions in the Andes, and his change of point of view is manifested here in this. And of course, he describes all the changes in plants and all the tiny little squiggles here on the right-hand side to the green in the center of the drawing. These are the different plant species he identifies. Many of them have not been actually described before, so he names quite a few of them himself, and he contributes enormously. I'll say this later again, but he brought literally tens of thousands of specimens home with him, and this, of course, changed the course of science dramatically. So then, after a South America spell, he goes up to Mexico. As I said, he stays in Mexico for some time, and he returns to Europe via the US, where he meets the president, and then he settles in Paris after his return to Europe. Paris is the place to be, and this is where he gets a lot of attention. And he writes his observations from the different places. He compares the different areas where he's been. He notes that these vegetation changes, they are very typical, and he finds them in almost all places he visits. He gives a lot of lectures, and his lectures are very famous. A lot of attention is given to his lectures, and some people said they were like musical concerts at the time, so he has a lot of charisma. So here's a few impressions of a maturing Humboldt, and he's getting a little older at this point, and here you see him in this kind of image on a stamp, a German stamp from a few years ago. So this is where he starts to settle. He doesn't travel quite as much anymore, but he thinks a lot and writes a lot at the time. So when it comes to his accomplishments, he not only did make contributions to botany and our understanding of volcanoes, but he also triggered at the time what was known as the guano fever. So he actually took some samples of guano from his travels. Well, you know what guano is, it's bird excrement, and he brought this back to Europe and he had it analyzed. And he realizes very quickly that, similar to volcanic particles that are good for agriculture, guano is very, very good for plant growth. And with this observation, he kicks off a guano boom. And this lasted until 1845. And later, of course, we had artificial fertilizers that we developed. But in that time, there was suddenly a rush to get guano from the southern hemisphere and use it all over the world to fertilize one's field. And this goes back to Humboldt's initial observations. So when we think about Humboldt's accomplishments, Humboldt collected 60,000 plants and animal specimens, which he describes and brings back to a large degree. He recognizes also, because of his travels, that oceans have currents. He figures out that sailing in certain directions is easier than in others, and, well, the Humboldt current is named after him. And he recognizes that many plants have medicinal use, so they can be used as remedies. This is what he learns from the native people in the Andes, and he describes this. And he also develops his next step of the big botanical concept, and that is he comes up with climate zones. And there is an image here to the right. This is not drawn by Humboldt itself, but this is drawn later from his descriptions. And he notes that there's different climate zones in the planet, and they change with altitude, but also with latitude. And this was his important observation here. While he has not actually graphically represented this himself, this image in the top right was done later on, as I said, but he understood the systematics and describes it in his diaries. So what he did, however, was he had a lot of these section drawings that he did, and this was pioneering the way we do things, we illustrate things, and he was a pioneer in scientific illustration in this context. So here we have these changes in altitude, the botanical changes with altitude that also hold true on the globe as a whole. So his understanding of nature was really opening up the way we look at things today, and he was later, of course, challenged by Darwin. Darwin was very impressed with Humboldt, and Darwin, in his diaries, we actually note that he only took the great journey on the Beagle because he wanted to compete with Humboldt. And Darwin had a somewhat more radical view on how nature works. For Humboldt, everything had some sort of equilibrium. Everything was in sort of balance, and this is what influenced a lot of people later. Our concept of national parks still goes back to Humboldt because we believe that there is some sort of an equilibrium in nature, and we like to preserve it. But of course, this is not always true. Some equilibria are actually metastable, and Humboldt didn't quite want to accept that, and Darwin was a little bit sharper on that. So, a few more kind of points. Countless places and phenomena are named after Humboldt, and he believed that nature is in balance. He has a massive influence, as I said, on people like Darwin, but also Muir, the father of the American national parks, and this is where the concept of the balance in nature comes from. But balance is only a temporary feature, as we now know, because Darwin quite rightly pointed out it's often about survival of the fittest. And what we see in our short window of observation may look like an equilibrium, but it may only be a very ephemeral feature. So, a little later, Humboldt returns to Berlin. His time in Paris comes to an end. It's not quite clear why that is. Some people say he was a bit homesick. Other people say he ran out of money. I am not entirely sure, but he returns to Berlin, and he is welcomed with open arms in Berlin. And he is receiving a Prussian state pension, and he starts to lecture in Berlin, and he writes the famous Cosmos lectures, which are also published as a book. He does a few more trips. In 1829, he travels all the way to Siberia, believe it or not, and the Cosmos lectures are then published eventually between 1845 and 1862 in several volumes, which adds to his fame. So this is an aging Humboldt now, several illustrations of him. So this is just to give you an impression. And this is a very old Humboldt now in his study back home on the family seat. And there's a few more of those. So here you see him in his library surrounded by specimens and a lot of books. And he was very studious and very productive all through his life. Then later on, there was the first photographs being possible, and indeed, Humboldt was also photographed, and we have this one photograph of him as a very old gentleman on the right-hand side, and so you get an impression of him, but now as a very, very old gentleman, of course. So he is eventually buried at his family seat in Tegel, and there's a few impressions on the left-hand side. There's a painting, but then also a photograph. And then there's this beautiful oil painting of him with, as an old gentleman in front of Chimborazo. Of course, there's something a little distorted here because at that age he wasn't back in South America. But it is said that in his mind he went back to Chimborazo many, many times, and this was something that really shaped him and his thinking. So this was a very important place for him. So the artist here put the old thinking Humboldt together with one of his major legendary feats at Chimborazo. So, here's a few more aspects about his legacy. He was quite a man with foresight. He warned about deforestation already at that point, and monoculture was something he was thinking is not a good thing, and he produced various pieces where he said, if humans continue as we do, climate change will actually be induced by our actions. Can you believe it? This was 1799. He had a very holistic view of nature, and the living world and the interaction with humans was very important to him. He was one of the first to realize that our actions actually affect nature and they will change nature, and that this is not always in harmony or in balance with nature. Later on, Darwin, who was, of course, a great admirer, but at the same time he also needed to make an impression. He wanted to, of course, show how smart he was. He developed a much harder view, and that is of natural selection, that a stronger or more adaptive species can actually replace another, and that equilibrium is not something that can be maintained for any length of time, that there's always flux in nature. And that what we consider today as equilibrium is only a very temporary, a very ephemeral thing. So, he already warned about deforestation, as I said, and here some of his drawings kind of show this already, that the agriculture is changing the way the forests grow, and he makes notes about this already in some of his sketches. And although he's never been to the Himalayas, he studied a lot of accounts, and he sees these changes already in those areas. So, he eventually is credited for inventing botanical geography. He recognizes the interaction of geology, landscape, geography, the living world with nature. He pioneered data visualization, and the most important thing, more species and places are named after Humboldt than any other human being on this globe. And I'd like to close here with a few impressions of this. So here you have Humboldt County in the US, you have the city of Humboldt in Canada with the red brick town hall there. And he's on various, stamps, and the Humboldt Current is named after him. There's even the Humboldt Broncos, a sports team named after him, and of course various drinks from the Humboldt distillery, etc., etc. So he really had quite a large influence, although maybe he got a little bit forgotten. So I think it's important we remember him. Thank you very much for your attention.